Hey kids, Mr. Murray here, and another example of finding the extreme values for a function, aka the absolute maximum and minimum values for a function over a closed interval. As just a quick recap, that if the function's continuous, which e to the x squared minus 6x is, it's never undefined, it's continuous, then it must have a maximum and minimum value, and that will occur at either one of the endpoints or one of the critical points within that interval. So we employ what we call the candidates test here, and the candidates for the absolute max and min are the endpoints, -4, +5. Some people like to plug those in right away, totally up to you. And the other candidates are the critical points, if there are any. So we get that from the derivative. F prime of x here, if f of x is e to the 6x squared, e to the x squared minus 6x, then f prime will be e to the x squared minus 6x, got to use a little chain rule here, times the derivative of that exponent, which would be 2x minus 6. Okay, so that's our derivative, and we're looking for where that is 0 or undefined. And this expression is never going to be undefined, so let's just get right down to when it's 0. So the beautiful thing here, it's already in factored form. I can just say, hey, when does this equal 0? Or when does 2x minus 6 equal 0? This is a pretty easy one. Add 6, divide by 2. You get 3. That's definitely a critical point, and it's definitely in this interval from -4 to 5. Remember, we only care about critical points in the interval, obviously. And where does e to the x squared minus 6x equal 0? Hopefully you realize that that has no solution. If you don't realize it, then I guess you've got to take the natural log of each side. Right, the natural log, and of course leaving you with x squared minus 6x equals the ln of 0, but the ln of 0 is undefined, so this yields no solution. And just to sort of backtrack here, also, using your graphing properties, you should know e to this, that thing is never going to equal 0, no matter what x value you plug in. Those exponential functions, they had horizontal asymptotes at y equals 0 because they never got there. They get infinitely close but never get there. So our only critical point in this interval is +3. So we've only got 3 candidates here to test, and to determine which one's the max, the min, we just plug them into the function, right? Now without a calculator here, we're doing f of -4, f of 3, and f of 5. So you got to use your head a little bit here. We get e to the, when you plug in -4, you're going to get 16 plus 24. That's going to be e to the 40th power. And that's the way I'm going to leave that without a calculator. I'm not about to try to estimate that. F of 3, you're going to get e to the 3 squared is 9 minus 18, and that's going to be e to the -9th, or 1 over e to the 9th. Definitely a very small value, very close to 0. And f of 5, we get e to the 25th minus 30, so e to the -5, also a small value, 1 over e to the 5th, but not as small. Hopefully you're making this conclusion right along with me. 1 over e to the 5th is small, but not as small as 1 over e to the 9th. So here is your minimum value. Here is your maximum value. That's definitely the biggest. And like we've said before, I like to answer with a sentence. That way you're covered no matter how the question is phrased. The max value is e to the 40th. Remember, you're talking about the y value when they ask for those max and min values, the output. And and I like to say which occurs at x equals -4. This will be especially useful when we apply this to a lot of word problems later in the year too. The minimum value is 1 over e to the 9th, right? And that occurs at x equals 3. And just for a little visualization, as always, let's take a look at this graph. Let's see what we're dealing with, in a concrete fashion. So I'm going to bring this in. You'll notice I put the original f of x function there as y1. Let's take a look at its graph. This is on the standard -10 to 10 viewing window, and you can see it kind of looks like a parabola, but it's super flat there. Not easy to tell where the vertex is. So this is where I'm just going to set my window to be exactly the window I cared about in this problem. Let's see, we'll take a quick look here. We were going from -4 to +5, and our smallest value was still not bigger than 0, so I mean, put something close, -5, I don't know, but my y maximum was e to the 40th. E to the 40th, that's a huge number. I mean, I don't know how huge you think it is. I'm just throwing 500,000 here. I haven't even checked this decimal value, but and you can see, when you scroll to the left, the important thing is I thought the maximum value was at the leftmost endpoint, and you can see that that is definitely the case. As you scroll to the left, look at those y values. They're huge. It's way off the screen. And as you scroll to the right, that's where the values are coming down here. There you go, and you're getting really close to 0, 0, 0. Look at that. Watch the y values in blue. If you're zooming in there, really small, and even further, because let's take a closer look here, because I thought at 3 that's where the minimum value is. So let's take I could just zoom in, or I'm going to go from 2 to 5. I really want to look at that portion, and I'm going to set my window from 0 to, those y values were really small. Let's just see, like 0.001 as my y maximum. So this is really zoomed in. And now you can really see, like, of course it didn't look like that when you're zoomed out, but look at that. Look at that value happening right in the middle. And if you hit the trace and you just tell it to go to 3, for example, you can see that is the lowest point on the graph, and that decimal is the equivalent of 1 over e to the 9th. And if you tell it to go to 5, look at the y value. Of course, that's still a really small value, 0.006738, but still, compared to what it was at 3, it seems huge when you're on this scale, when you're zoomed in. So 0.0001. So just again, a further confirmation that your algebra is making sense, and it's nice to sort of have a picture of like what you're finding with algebra, like what that must be going on. So you want to develop that ability to kind of put a picture together in your head based on the numbers you're finding. So hopefully this is making sense and you're enjoying it even, and as always, reach out if you have questions. Hang in there.